Okay, so let's look at some common function interfaces. So for that, let's start with some example, which is the new a few new methods which we find in Java 8 from collection framework. Fine. Let's start with something from the collection framework. So we know those methods of the collection interface. Let me come to this board. Okay, so we have the collection interface. Now look at the way we normally, suppose I have a collection of string, very simple example. I have a collection of string and I want to print them. I'm taking example of just printing, but it could be some more complex things that you might be doing. Okay, or maybe I have a collection of accounts and I need to update the interest in all the account objects. Fine. So you might have a method called update interest, which is available in account. Fine. You want to invoke a particular method on all the accounts in a collection. Okay. So our normal code would be, so I'm assuming we have a collection of account, let's say, right? So there's a collection of account. Okay. Accounts. Fine. So the code, the conventional code, what would you do if you have to update all the account objects in this collection? Collection is iterable. We can use the for each loop. Fine. So that means we can do something like for each account in accounts, and you'll say, okay, account dot update interest. Maybe if you might have parameter, you may not have parameter, whatever, but you are invoking a method like this. That's what you're doing. And that's the way you write your code. Okay, what you are doing here is you are doing it sequentially. That's one thing. You are doing this all sequentially. You are picking up the element from the collection. Picking out an element from the collection. This is nothing but your object coming out of a collection. Extract the object from the collection. Do something on the object. Fine. What you are doing is a fixed thing. Rather than taking out the object from the collection, every object from the collection, and applying a function on it, give the function to the collection and say apply this on all our elements, all your elements here. Fine. So let's see this, how this could be done in Java 8. Okay, fine. So so this, instead of all this code, you could have written something like this: accounts dot, so you are interacting with the collection itself, and you're saying for each is a method, and what we give here, the action to be performed. What's the action to be performed? Update interest. Okay, so okay, for each. Now this for each would have one parameter. It's a function which is going to pick up, which is to be applied on every account object. So I would say AC, and what is it that I'm giving? AC dot update interest. Fine, maybe it doesn't have a parameter. Fine, I'm assuming we don't have a parameter there. Okay, the update interest has no parameter. Let's assume that. Right? A shortcut for this would be dot for each. What's that? AC dot update interest. No parameters. Okay, what did I pass here? What is this function? Look at the signature of that function. It has one input, returns void. It's about taking action on given object. You are giving me an object and I'm going to take an action on it. This kind of object where this kind of a function, now it's a function where you give one object on which some action needs to be performed, return type is void. These are known as consumers. These are known as consumer. Fine, so we have a functional interface as a general interface, and so there is a functional interface called consumer. So this is now part of the java.util.function package. We have this package java.util.function. This has got 43 functional interfaces, but these are categorized as of the kind. So there is a kind called consumers. Okay. What is a consumer? A consumer is nothing but a function which may have some inputs, okay, but doesn't have a return value, return type void, those kind of methods which return void. Okay, they may have inputs, so we call them as consumers. So for example, we have a consumer of T. So it's a consumer of some type T. That's one of the consumers. We have another in the same category, there's a buy consumer. Buy consumer of T comma U. Return type void, but two inputs. Those inputs could be, it's a generic, so you could be having anything, right? You have int consumer, so for primitive types, right? See, these generics, when we talked about generic, those generics, they only deal with the reference type and not with the primitives. Fine, you can't say, okay, I want to have that account with int. It has to be integer, not int. Okay, so for primitives also we have consumers. For example, we'll have the int consumer. What would it be? Some function which takes int as a parameter. Here, let me put the method name. For all consumers, the method name is accept. And they have only one parameter, and that parameter, in this case it is T, for consumer it is T, return type for the method would be always void. When a function with return type void, so when I say consumer of T, method name is accept, parameter is T. When it's a buy consumer, method name is accept, parameters T and U, return type void. When int consumer, parameter is primitive int. And so that way we have got consumer, that's one category. Consumer is return type void. Okay, they don't return, they just consume. Fine, we can have a look at the list here. Yeah, the common function interfaces which we find in the java.util.function package. Fine, what do we find? One category is predicate, the other is consumer. What is predicate? Something to test. So it takes inputs and then tests some values and returns a boolean. Return type boolean, that's a predicate. Return type boolean. When I can give an example of a predicate. Okay. When we have been using predicate earlier, because these function interfaces are not some new interfaces, but interfaces which are existing got categorized as function interfaces because they have only one abstract method. Okay. So example, find some such example if you want to look at would be from the fine, if you recollect, in the file class we have a method called list or list files. What's the parameter? a file filter. Fine, the filter. Okay, what is this? Single abstract method called accept with two parameters, no, one parameter file and return value boolean. The method here is a return value boolean. So when I say list files, fine, now I can use a lambda. I can use a lambda. Fine, I can use lambda like this. I'll say, okay, given a file f, fine, f dot length less than 1024. I want all the small files. Fine, I want to filter out only the smaller files. I want only those. So where this expression evaluates to true. And that's an example of a predicate. So if you look at predicate, fine. Here also we have predicate of some type T. There's a by predicate. And we have predicate, we have a by predicate, two inputs, but return boolean. We have int predicate, long predicate, double predicate. See, for as far as primitives are concerned, three primitives have been considered, int, long, and double. Okay, if you look at it here, okay, let me just explain what are these. When we say predicate, return type boolean. Fine, there will be inputs, return type boolean. When we say consumer, no return, return type void, return type void. And when we say supplier, no input arguments, zero arguments. Return is only one value, and so they are supplying. And see, I talked about a constructor reference, right? Common examples for supplier. Fine, when we write a supplier, very commonly we would result in writing a constructor reference for them. It would be easier there to use the constructor reference. There would be the examples for constructor reference. And suppliers are very easy, fine, because you might be writing a function which just says, okay, for example, someone says, I need a list of something, right? So it's a supplier. It needs to return a list. So I'll say, okay, as a supplier, I might say array list : new or vector : new. Fine. So it's a supplier of list. A supplier of list would be like that. Fine. A function. What is a function? TR, right? In general, TR. One T is the input, R is the return type. In general, if I consider any function with one input and one output, TR, there's a by function. So function has its own category, but it has a return value. There are inputs and there are return values both. Return value will be only one. Fine. So there is function, there is a by function. Now a unary operator and a binary operator are special cases of function. And when we say unary operator, it would be one input, one output, fine, just like a function, but the type of both of them is same. Whatever is the input type, same will be the output type. When it's a binary operator, two inputs and one output, but types for all three is same. And that's why it's binary operator of T. Fine. Let me check the next one. So here are the predicates. There are 5 predicates, 5 different type of predicate. Fine. So when I say predicate of T, the method name, I should have mentioned the method name. The method name here is test. Yeah. Method name for predicate is test. Oops. It always comes on top. Right. So if I say predicate of T, fine, it would have a method called test, parameter is t, and return type boolean. Fine. Okay, so same way. Now if you have a by predicate, two inputs t and u, return type boolean. Int predicate, input is primitive int. Fine, it's not generic here. Fine, it's fixed. Int, long, and double. So that way we have those are from the Java util. These are the 5 predicates. And return type boolean, that's the point. And method name here is test, all the places. Okay, method name would be test. The parameters are different, that's the only thing in each of those 5. Fine. Clear? Now I'll give an example of use of a predicate also. We can have a look at the use of predicate somewhere. That the file filter which I was talking about, that's actually it's not exactly matching it's not exactly a predicate, fine, but it's just like a predicate from the point of view of writing a lambda. See, when I just simply write a lambda, right? See, okay, I'll just slight deviation, but let me just explain one more point. Object is super type for everything. O, or let's say obj equals, and if I put some lambda expression, what do you think? Valid or not? Some lambda expression, any. You can put the one for comparator or anything. This is not valid.
Has to be applied to all
because this thing, the type cannot be inferred. I don't know what is the type. Fine. Java is strictly type. At compile time, type for everything has to be known. Has to be determinable. Fine. You can put that. Okay. Fine. Clear? This is not assignable. If at all you want to have an assignment, you would have to do a casting first. Cast to the functional type, what it is. Mention the type for it. Fine. Here, the type is not known on this side. Fine. When instead of object, if I put a functional interface type, it can determine from that, from the usage, from the context, it knows, okay, this must be the type. Fine. So there is an inference which is working there. Fine, it is working. You can cast. Okay, you are writing this function interface. This is lambda. So this is a method. That method matches something somewhere in a function interface. You can use any of those function interface type. For example, if I am writing something which returns a boolean value, right, and I am saying file f maybe, right, it is saying file f, right, and there is some boolean expression here. If I am writing this, what is the type for this? It's not necessarily a file filter, it could be a predicate, or it could be, you could also have defined a function interface which matches this. And many times I don't even give this, right? I don't even mention the type here. Right? We don't give that many times.
Casting should be a type of functional interface.
Yeah, because yes, you will have to cast to some function interface. It's a lambda you are writing, so it's a function interface. Lambda is an implementation of a function interface. Okay, so type has to be, just a lambda expression has no type. The type for a lambda expression is determined from the context where it has been used. Fine. Lambda only you can see is the method signature, and that method signature, it's a method in any functional interface. Okay, now coming to the usage of the predicate. Okay, in the collection framework, that collection of account, fine, we have accounts, right? This we have, fine, we can assume this, and from the list of all the accounts, from a collection of all the account objects, I would like to remove those accounts which have balance less than 0. I want them to be removed. Yeah. Accounts dot, we have this method. Okay, I'll give the method first. So in the collection framework, so if I look at the collection framework, okay, let me now give the method signature. Our collection of E, that's an interface which we have. Fine, collection of E has all those add and other methods. In Java 8, we have a additional method. Now, method addition always has a default. So we have a default method, one which returns void. Okay, is the method called for each. What's the parameter? Consumer of question mark super E. So you are giving an action, a function which can take an action. Fine. That's a for each method. This is additional method in collection. Fine. That's how you are passing a consumer. And we saw example of saying for each and then passing the function. Okay, update balance, right? Update interest. Okay. Similarly, another default method. So let me put the other default method which we have. Return type is void. The method name is remove if, and what's the parameter? Predicate. Predicate of question mark super E. Fine. That's the test basically. The parameter name they call it as test. So all those who pass that test will be removed. They will be removed from the collection. Clear? We don't have to write a for loop now. We don't have to iterate them. And when we use for each, it's not necessary that the thing is done sequentially. It might be distributing into several concurrent partitions and doing parallelly on each partition.
So internally
It can do that, yes.
benefit of multi-core processor.
And you don't have to worry, it's in the library now. That for each is a method from the library. You are not worrying about how concurrency is to be handled.
So it can take benefit of multiple processors.
Yes, it does that. And it looks at your core. How many cores are there?
Yes.
Core, fine,
Multi-core.
multi-core. So all the cores, it will just count the cores and then accordingly distribute.
Main benefit is better utilization
Of the processing power, yes.
Which is not possible in JDK 7.
I won't say it's not possible, but it would be quite a tough thing.
Tough.
for you to be writing that kind of a code, you have to write the code for the concurrency.
Manage it.
Yes,
It's internally managed.
it's in the library,
Yes, it's in the library.
and the application developer doesn't worry about it.
Yes.
Are there any APIs to monitor this parallelism?
There are monitoring tools separately.
Monitoring
Tools are
JConsole and
yes,
JConsole.
How a program, which core it is getting executed, something
not
like that?
which core exactly.
Or like how much percentage of time it is taking on each or something of that.
Yes.
What is the name of the tool?
If you are just looking at what percentage is used where, okay, which core is used how much, that would be available even at the OS level. Java tool need not be used there.
No, but precisely for this program that
Yeah,
we
yeah.
are executing, it will be possible. Because it will be a general thing.
No,
Like,
processor wise also. In the proc folder, not in Windows, on Linux. Yes, yeah.
in proc folder.
Yeah.
Windows is there anyway?
We'll have to check with Windows.
So if you want to put this kind of application will have most of
Yeah.
the Windows. Yes. The clients.
Fine, so same way, remove if. Okay, so how we could use this? We could say accounts dot remove if given any account AC dot get balance less than 0. That's the whole thing. There's no for loop, nothing. No iteration over a structure. Give the function to the structure, give the test to the structure will do it for you. It's in the data structure now. You don't take out the things from the structure and then work on it. Fine. Give a function to the structure takes the function and does it. And passing functions. Fine, you would have taken it out from the function, from the structure. In the earlier case, what you would have written is a for loop, take out the object from the structure, call the test. Call the test yourself. So you write that code, right? Taking out something, fine. And it's not considered good to take out something from the structure and then work on it. That's prone to errors. It's prone to errors. Yeah, you may be good, quite efficient, right? But the code in the library is from the experts. Okay. Right? Okay. And clear on this? Predicate, consumer, two things. Third type was supplier. Okay. So supplier is nothing but if I just put the signature, supplier of some type T. There cannot be two parameters here. Supplier of some type T has a method called get, okay, return type T. So there is also int supplier, long supplier, double supplier, and a boolean supplier here. In this case, even a boolean supplier. So that's why we have 5 supplier. You can continue here. Yeah, this is predicates. Fine. I think the signature for these predicates should be okay. Name of the method is test for predicate. Okay. For consumer, there are 8 consumers. So there's a consumer of T. Method in consumer is accept. In all these interfaces, the method name is accept. Fine. Parameter, first one has only one parameter, type T. Return type is void in all these. Okay, now something about the consumer itself. Let me show one example of consumer. Fine. There's a default method in consumer. Fine. We can have a look at that.
Except
Hmm?
that is the except.
No, default method. That except is the abstract method, but we have some default method. Okay, and then the name of the method is and then. I'll explain what it is. Okay. What is so for a consumer? It's a
Object long is you're talking of wrapper classes here? Long, double, and
no, they're primitives.
object int.
Okay, the obj int consumer, when I says obj int consumer of t,
Okay.
so it is t and a int, two parameters.
T and two
Yeah,
parameters.
two parameters. Fine. First parameter is the generic one, second will be the primitive. Return type void, obj int consumer, fine, obj long consumer, obj double consumer, fine. So two parameters basically, those are all with two parameters. One is primitive, one is the generic one. Okay. So yeah, so just another case of, we have this consumer of some type t and it has a default method to return a consumer of t. This method returns a consumer of t. The method name is and then, and takes a consumer of t. That's our action. I'll explain. I'll give an example where it could be useful. I have this class account, right? In this class, we have a method called display used for displaying the details of the account. We might have a method to print the passbook, and we might have, okay, these are something like this. So I have, let me put it like this. You have a consumer of account. The idea is to have a consumer of account. One consumer which has been defined is, let me call it C1 equals given an account display. Fine, account colon colon display. Fine. Consumer 2 is given an account colon colon print passbook. C3 equals given an account, find the email ID of the consumer and send him a statement. Given an account, I am taking different actions. Fine, each one is a consumer. I have different things which I can do for a given account. So for each one of them, maybe I already have various small consumers created. And then I'll say, okay, for this particular, if this particular event happens, I might have to do the printing of the passbook, sending of the statement, and sending an SMS. I select what all should be there. So I'll say consumer, okay, C5 equals C1 and then C3. Combine C1 and C3 to create C5. So it should first do C1 and then do the job of C3, and that's a new consumer for me. Combining consumers to create a new consumer. Fine. So you might have small consumers, and for certain cases now you start combining consumers to create consumers which are doing more job. Fine. So consumers. Consumer has default method there, right? For combining.
Is there any restriction on appending and C5 equal to C1 and then
Dot
C2
and then dot and then yeah, put anything.
And it will follow the same sequence. First of all, it will perform C1 and then.
So you are creating one more consumer. That's it. See, when we create a consumer, nothing happens, right? It's only creating a new function. The place where you are defining is only creating a function. It's not executing. It's not executing. Someone will have to call C1 or C3 dot accept. When someone calls accept, that's the place where the execution of those things happen. Otherwise, it's just creation of a function object. The place where you are writing a function, no execution of that function is happening. It's just creating a function object. And think of this as a function object. Right? See, when I was saying AC1 dot set penalty, and I was passing a function. When I was invoking that set penalty, no execution of the function was happening. Okay, it's only that some function object was created and set in the instance variable, but execution was not happening. That function is not executed the place where you see that function. That function is executed when someone was calling the withdraw method. In the withdraw method, we had invoked compute and AC1.compute. Not AC1 this dot, fine, it was penalty.compute, right? We had called penalty.compute.
Can we combine predicates and consumers? Because, like, for example, in
Predicate, yes, predicate, not predicate and consumer, but we have predicates being combined to create new predicates. Even predicate has those methods. Which are those methods? And, or, not. We have three default methods in predicate. Fine. So P1 and P2 is another predicate. It's a test where both the tests have to pass.
So in this case, if I call accept method on C5, it will call accept method on C1 first.
And then the accept method of C3.
It will follow the same sequence.
Yes.
one more, in the earlier predicate, we took an example of predicate and we were testing whether the value is minimum balance is less than 0
Yeah,
and
yeah.
we want to remove it, right?
Yes, remove if.
Before removing, actually physically removing the element, we
Yeah.
also want to send the SMS intimating the account holder stating that your account will no more exist.
No, that would not be in this, not in the remove if. It's not part of the remove if.
So we'll have to perform two operations separately.
Yes.
But in predicate, we were checking also and then removing. In between, we want this
No,
SMS to be sent.
predicate is just a function. The remove if is the one which takes such a function which can return a boolean value. If that function is doing some action, see, what was that function? What was the action? Okay, what you could have done probably there was, here you could have done this. AC, you're saying AC dot get balance, right? So now remove if I have to pass a predicate. Now given AC, now before I say this, right, I might have, then in that case I might have written a code which says if AC dot get balance is less than 0, send an SMS, the code to send an SMS, and then I'll say return false, return true here, otherwise you are returning false, return true. Yes, AC is this needs to be removed, so return true. But you might have, because you have the object, you might have taken the action in that function itself. The predicate is taking some action. It would be, but predicate has to return a true or a false. But this is not a good practice. And predicate is meant only for testing and not for changing the state anywhere. Fine. Fine. Functional programming assumes that you keep the immutability of objects. You don't change the state. Fine, this is fine. Okay, let's proceed. Okay, so we have the consumer. When combining consumers, same way we can combine predicates to create new predicates. And you can look at the API for that, right? Okay, fine. For combine, fine. We have like the methods, default methods available in predicate, and with another predicate to return a predicate, or with another predicate to return a new predicate, and not. No parameters for not, but returns a new predicate. Okay, so if you already have some predicate, right, you could say not of that, and that would be again a predicate. So predicate dot not, sorry, whatever is the p1 dot not, no parameters needed, it's also a predicate. Yeah.
In case of and or, the way we have partial execution of the expression, if the first portion of the expression itself is false in case of and, will it by default return false, or it will check the full expression and then return false?
It should return false, the first place.
The first sub expression itself is evaluating the whole expression.
Yes. Okay. Fine. Clear? Predicates. Predicate, consumer. Okay. Supplier only 5 of them. Fine. 5 suppliers. But now the thing is about a function. Function in general is t comma r. Okay, method names for function. So if I just represent as a box, fine, if this is my function, input is t, output is r. And that kind of a function. The method name in function is apply. So apply has input as parameter, there is t, return type is r. Okay, there is a by function of t u r. So input would be t and u, and return type is r. Fine. Int function, all those different types of functions are there. Fine. We have that function list there. Okay, but here again we have something like and then. Okay. So we even have methods like this. In function of t comma r, okay, there is a default method. Okay, the default method returns a function of t comma u. Name of the method is and then, and the parameter to that would be a function of r to u. See, this you can understand how it happens. I have a function, fine, whose input is t, whose return is r, fine, and therefore I need another function if I have to apply next one, whose input should be r, and it would have some output, I am assuming that is u, and therefore this entire thing become a function from t to u. So that's what is returned. So you combine one function after other and then you get a new function. And so that's a default method, function, and then. So in function, Like we have the and then method, there's also another method called compose. It's the other way around. Fine. So there's another default method. Fine. This we say, this is the, when we say and then, the method here is the one which is after. And we, this is not, so this is the one which will be done after, right? So after the current method, use that other method, right? But in case of compose, it's the one which is before. So we have the method called compose, and it would return a function, fine, where it is from R to double R, let's say. Okay, not R to double R, sorry, U. Let me put it as U. Fine. The current function is from it's like, okay, the other function which I am passing is the one coming before. So U, the input for the other one, no, not recursion, it's just the arrangement is the other way. Okay, so because I am currently looking at T comma R, on a T comma R, okay, so here is TR, right, this is T, this is R, okay. If I want to put something before this, that's the other thing's output should be of type T, and it has some input type that is your U. So it is from U to R, okay, U to R, only R. It's a function from U to R, okay. Name of the method is compose, and parameter to that would be a function which is from U to T. And the method on which I am invoking is T, and this is the method which is before the current method. So that would be a new function. And so functions to create new functions, combining functions to creating new functions. You have smaller functions doing small things, combine them and you can have placing. And when we say compose, okay, this is the one which has to be done later, the one on which I am invoking the method. F1 dot compose F2. Then the function which is created is first calling F2. The output of F2 is used and given to F1.
But same thing can also be represented as and then F1.
Then you should have said F1 dot compose F2 is like saying F2 dot and then F1.
Yeah, exactly. So there are these
Yeah.
Complementary.
Yeah. Fine. Function of T comma U. Okay, let's look at the whole list of what all types of functions we have, right? So this was fine. Consumer list is okay. When I say consumer, by consumer, int consumer, long consumer, fine, long, double, and now obj int consumer is 2 parameters. When obj int, obj long, and obj double, these are 2 parameter consumers. When they are having, oh, that's not mentioned, they have a type T. These are generic. These 3 are generic. The last 3 are generic. So they take T as a parameter. Just put T. They have a T as a parameter. They are generic.
The last 3 forever classes here, not for primitives.
They are a combination. First one is a T. Second one is a int. Two inputs. Like by consumer has 2 inputs, but both are generic, T and U. here obj int consumer has two inputs, so two parameters. First one is t and second one is int, the primitive. So obj int, obj long, obj double. Fine. These are with two parameters. These are all three are generic with one type parameter. Okay, all these three are generic with one type parameter t. Right. Okay, suppliers, right? They have one additional, that's a boolean supplier, primitive boolean. Okay, that's primitive boolean. Right? A method to return primitive boolean. Fine. No input but returns boolean. Fine. When someone can write a long supplier saying, okay, anytime if you ask for what's the current time in milliseconds, and that could be a long supplier. And no input, but yes, I'm getting it from the system time. And these are the function. Okay. Fine, there are 17 different type of things in the function. And I said total of 43 interfaces are there. So these are those 43. So function tr, right? The name of the method, now just method naming convention, let me tell you. First is all method names normally are apply. We have these methods which are saying toInt function, right? Or toLong function, toDouble, toInt, toLong, toDouble. Fine. There the method names change to apply as int, apply as long, apply as double. Okay. Now you look at these method, the function interface, these are names of interfaces. Okay, these are all interface names. The methods in the interface name is apply everywhere except for, and it's just apply, okay, except for in case of these methods, these interfaces called toInt function and the toInt by function. We have those two. There the return type, when it says saying toInt, what's the return type of that method? Int. The name of the method is apply as int, apply as long, apply as double. Otherwise everywhere the method name is simply apply.
So it will return as int. It will also take parameters as int.
Okay, those are the ones like this. When I say int function of r, what's the input? Fine. Okay, let's see each of them, right? Function tr, apply, parameter is t, return type r. By function tur, parameters t and u, returns r. Int function of r, parameter is int, return type r. Okay, fine. Long function, double function on similar lines. toInt function of t, parameter is t, return type is int, and there the method name is apply as int. Okay, fine. We have the apply as int, same way. Fine, this also has apply as int, but this has got two parameters, t and u. Return type is int, but so I given two parameters, but it returns a int value. Okay, and these are nothing. See, each of these function interfaces are just representation of a method signatures, different kinds of. So 43 different method signatures. That's what this java.util function is. The entire package is commonly used method signatures. And toLong, toDouble, right? And then int toLong. When it is saying int toLong, parameter is int, return type long, and what's the method name? Apply as long. Yeah. So apply as if the return type is primitive, then the method name is apply as and that primitive. That is the convention that is followed. Fine. So these are 17 functions. Fine. Okay. This PDF anyway I'll share. Fine. Okay. So next one is the unary operator and the binary operator. Okay, these are nothing but special kinds of function only, where the type are same, all 3 or 2, right? When it's a unary operator, method name is apply. Okay, unary operator method name is apply because it is anyway inheriting from function. When unary operator says it of t extends from function of t comma t, that's how they have written. Okay, it's extending function of t comma t. Fine. So unary operator apply t returns also t. Both are same type. Then we call it as unary operator. Fine. Int unary operator long and double primitives. Input primitive, return also primitive. Fine. Same way with the binary operator. Okay. And there are 4 of them. The last one is double binary operator. Binary operator means 2 inputs of the same type and return of the same type. Okay, method name will be apply as int, apply as long, apply as double for the primitives. And other one is apply.
But it takes
2 inputs, binary. 2 inputs, but return value is 1.
And both inputs should be of the same type.
Both, yes. When it is operator, the types for everything is same. Okay, so that makes a total of 43. Yeah, so questions. Yeah.
We were discussing about parallelism.
Yeah.
These collections are executed on multiple codes. Is there a possibility that, and you also mentioned something about maintaining the immutability of the object?
No, it is not maintaining.
It is not?
It's not maintaining. It's not maintaining. You are supposed to maintain that. It's when we have functional programming style, when it is best that we don't
Mutate.
change the object state. We come up with new objects. Function takes input, returns something. Give it to the next function, it will create a new thing, right? And proceed further.
A lot of memory space would be
Yes, it would take more memory space. That's correct.
My question was on those lines. If
Yes.
you are implementing something parallelly and also updating the collection, would the collection get updated after all the core executions are happening, or as and when the changes are required, it will go and write it back?
We don't. It's not going to update a collection. Okay, like remove if and remove if is only doing it. The change in the collection. Now remove if doesn't matter. Parallel execution there would not matter.
Because okay, in case of but if we are updating something, then
There's no update which will do on a collection. By update you mean there is a list and you are trying to set objects in the list.
yes. Because
No.
our parents is equal to
Not available.
plus interest amount, something like that.
Then it's not the list, it's your object, it's the element. So it has nothing. So it's a method. I'm not writing a method for the element. That the one who has that return that class account has to take care about mutual exclusion.
That's what it should be.
He has to take care.
Implicitly it would be taken.
because this is about the collection and not about the elements of it.
In earlier case, we were taking explicit care of.
Yeah. Fine. Okay, no questions.
But the concerns are
yeah.
when we are talking of demo program, that's okay. When we are applying it on actual application like bank, there would be millions of records, right? And then we are trying to reduplicate things that would be ridiculous because a lot of memory space will be occupied. And so either we'll have to do partitions of the set itself and perform operations, keep doing the operations, write it back, and then we will have to take care of defining the application operation.
Same one thing. For example, we have a consumer, right? When we are writing a consumer for account, it is assumed this consume operation is not going to update the account.
Agreed. But in case if because we have to take care, na? In case if we are not taking care, then it can create a problem.
There are certain operations. We'll see. The main thing is still pending. That's about the stream. Okay.